Hello, everyone. Today we're going to start Unit 3, Module 9 Notebook. So we're going to kind of go back over. I don't know if you remembered at the beginning of the year, we kind of started talking about the Pythagorean Theorem, and that mainly dealt with right triangles. And we're going to go back to that and expand on that thought process. And then we're going to look at the converse. Remember, the converse is when we flip things around. But this first lesson is just about the Pythagorean theorem. So, what do mathematicians do after a snowstorm? They make snow angles. So, there you go. Miss Potter's always looking for different math funnies to put in. I hope you enjoy them. All right, this first section, we're going to look at applying properties of the Pythagorean theorem to solve problems. So, this is just a review. We looked at this again back in September, I believe. It might have been towards the end of August, probably more along the lines of September. It's been a long time ago, but we're going to review the Pythagorean theorem. Now, the Pythagorean theorem is used to find the missing side of a right triangle. Now, this doesn't work with any triangle. It has to be a right triangle. You have to see that square, or you have to see this angle being 90 degrees. Now, sides A and B are called the legs. So if any part, the sides of the triangle that touch the square are your legs, we call those sides A and B. Does it matter which side we label A and which we label B? No. As long as we're consistent, as long as once you start it, you stay consistent with that. I could say A, B, C, or I could say A, B, C. Side C is called the hypotenuse. Hypotenuse. The hypotenuse is the side across from the right angle. So I always like to use this as an arrow. Kind of points the way towards that longest side that doesn't touch the square, and we call that the hypotenuse. And we created the Pythagorean theorem formula where a squared plus b squared equals c squared. So you see a couple of labels over here. It says label the parts of a right triangle. This is a leg. This is a leg. And then we have the hypotenuse. Okay. Now it doesn't matter which way it's turned. Remember, the legs always touch the square, and the side that doesn't touch the square or is being pointed to is always the hypotenuse. So again, the Pythagorean theorem formula, the A and B values represent the length of your legs. In this case, we use 12 and 5. The C value represents the length of your hypotenuse. Plug these values in the Pythagorean theorem to solve for the missing side lengths. Okay, so if I were to do that, I have A and B as 12 and 5. So I'm going to pull up this. You're going to need a piece of paper, so you might have to pause the video. But my legs were 12 and 5, and that equals c squared. Now, today, you're going to want to use your calculator quite a bit, your TI-84 calculator on your Chromebook. Okay, it's going to be very helpful. Let me raise this up a little bit so you can see it better. Okay. Let me refocus in. So I'm going to take care of this side first. So I'm going to say 12, and then the squared button is right here. Squared plus 5 squared equals 169. So this is 169 equals c squared. And to finish that off, I'm just going to take the square root of both sides. And the square root is right here in the blue above the button. So to do that, you hit second squared 169. And so C is 13. So it's pretty straightforward when you use it correctly. Okay, if you want to insert a picture, go to the right place. Just take a picture of that. You can kind of stick it down here in the corner. That way you know. But that we've done several of these, so this is just the basics of that. Okay. All right. And again, if you hit the circle button in the bottom of your Chromebook and you search for TI-84, you'll have the app that brings up the calculator that I just used. You'll want to get familiar with that because it'll be very helpful on the work that you do. Okay. All right. Now, the type of problems we're going to look at today, okay, is these type of problems. So it says solve for x. Now, if I look at the triangle as a whole, if I just look at one triangle, I can't find that missing side. So I have to split it up where I need to look at the left triangle and then look at the right triangle. Okay, I have to kind of split these apart. So what that might look like on your paper is what I did is I just split the two triangles apart. So I have the left triangle here and I have the right triangle here. So let's look at this left triangle first. So I notice that these two sides touch this square. So I can just call this A and this B. Now I know what A is. A is 12. I don't know what B is, so I'm just going to say B squared equals, and then the side not touching the square and being pointed towards is my C. So that's 14 squared. Okay. So I'm going to just plug some things in my calculator. 12 squared is 144. And then 14 squared is 196. So I'm going to subtract 144 from both sides. B squared equals, and I'm going to take 196 minus 144. I get 52. And then remember, to get rid of that squared, I'm going to take the square root of both sides. So second squared of 52. I'm just going to round it off. B equals 7.2. So this is 7.2. Okay. Now I'm going to look at the other side. Again, I'm going to call A 12. I don't know what B is again. So 12 squared plus B squared equals, and this is C. This side isn't touching the square and it's kind of being pointed towards 29 squared. Now, I don't have to use the calculator again. I already have this figured out. 144 plus B squared. And then 29 squared is 841. So I'm going to use the same process. Subtract 144 from both sides. B squared equals, I'm going to take 841 minus 144. I get 697. And then I'm going to take the square root of that. Second squared 697. So B on this triangle is 26.4. Now, going back to my original problem, I needed to know the entire length of this side. So I figured this out was 7.2. I figured this side was 26.4. So how do I find the entire length? So all I'm going to do is I'm going to take 7.2 plus 26.4. 7.2 plus 26.4 is 33.6. Okay, 33.6. Now, it says insert work here for left triangle, insert work here for right triangle. We kind of did it all at once. You can split those apart if you want to. I would just kind of leave it like that and just show your work. Okay, so pause the video, take a picture, or go back and hit pause and insert this picture into your notes. All right, the next problem says solve for the missing values. So I have a couple shapes here. I have a triangle up here with 25, 16, and B, and then I have a triangle down here with 22A and B. So let's draw that out and see what that looks like. Now, what I've done here is I've kind of split the triangles apart. Now, I need at least two sides to find the third. The problem down here is I only have one piece of information right here. Okay, but since I split this part, I know that this is B. So if I find this, then that's the length I need here. Okay, so first let's identify our sides on this top triangle. This is a leg A, this is a leg B. They both touch the square. This side over here is C. It doesn't touch the square and it's being pointed towards. So if I set this up, 16 squared plus B squared equals C squared. So I'm going to go to my calculator, do a couple of things. 16 squared is 256. 25 squared is 625. So 256 plus B squared equals 625. So again, I'm going to subtract 256 from both sides. And once you do plenty of these, you kind of start to know how things go here. So I'm going to do 625 minus 256 equals 369. Now I'm going to take the square root of both sides. Second squared, 369 equals 19.2. We'll just approximate here. So B is 19.2. That means this down here is 19.2. So now I need to find A. So I'm going to kind of do the same thing here. I don't know what A is. I know B is 19.2. And then C, of course, is the side that doesn't touch the square, is 22. So I've set up the Pythagorean theorem again. Now we just did the square root of 19.2. If I square that, I know it's 369. And then 22 squared is 484. So I'm going to subtract 369 from both sides. A squared equals 484 minus 369. So 115. Then I'm going to take the square root of that. A equals 10.7. So there's my A. There's B. So I found all the missing parts. So I'm going to go back over here to the right place, insert image by camera. And there we go. Pause the video, make sure you finish up, and go on to the next problem. All right. This last problem is a little bit of a word problem. A 15.6-inch MacBook has a diagonal of 15.6 inches across the screen. If the screen measures 7.8 inches in height, what is the width of the screen? So if I were to draw, take a minute and draw what that screen might look like. So this is a computer screen, a laptop screen. Okay, it measures 15.6 inches from the diagonal from corner to corner. The height is 7.8 inches. I need to know what this is. So let's label our parts. Now I don't even need to concentrate up here. I'm just concentrating on this right triangle. Okay, so I might call this A. You call this B. These are both sides touching the square. And then this longest side not touching it and being pointed towards is C. So A squared plus B squared, which is 7.8, equals 15.6 squared. So 7.8 squared is 60.84. And then 15.6 squared is 243.36. So then I'm going to subtract 60.84 from both sides. That cancels out. A squared equals 243.36 minus 60.84, 182.52, and then take the square root of that. So second squared gives me that square root of 182.52. So the width is 13.5 inches. So this equals 13.5 inches. Okay. So again, go back to your notes. We're going to insert oops, I picked the wrong one. This is the one I wanted. Be sure and insert that in. And there we go. So this is the type of work we're going to be working on today. Please be sure that you follow the directions, look back on your notes, and get them filled out. If you have any problems, let us know.